Guys, in one more video I came about the Python, and in today's Python video I'm telling you about the how to deal with more than one exception in Python. So yeah, I'm telling you about it. So see the video start to and please like this video, share around, and subscribe to my channel. Don't forget to all the notification bell also never miss any future latest videos about the Python. So now without taking it any down, let's move to computer screen and let's do a coding with laughing. So guys, in today's Python video, I'm telling about the how to deal with more than one exception. So yeah, I'm telling about it. So let's get started. When you're handling a multiple exceptions in Python, you have several techniques at your disposal to catch and manage different types of errors efficiently. Here's a breakdown of the main ways to handle more than one exception. First is using multiple except blocks. First, you can have multiple except blocks to catch specified exceptions and handle each one individually. Number 2 is this is useful when you want to respond differently based on the type of error encountered. Like this one Python code, here you can see it. In this code, what we do in this code, first of all, we define a try and then we define a comment, some code that could raise multiple exceptions. Then x equals to int, then in the input I write like in the double commas enter a number, then result I write like equals to 10 divided by x, then I write like except value error, then in the print section I write like invalid input, please enter a valid number, then I write like except 0 division error, then here I write like print cannot divided by 0. When I save it and run it, so it say me enter a number. If I write 0, so it give me cannot divided by 0. If I write 5, if I run it and if I give 5, and now it give me nothing. When I write here like 10, so it give me here, and if I write here 80, and if I write here 90, and if I write here 0, so it give me it cannot divided by 0 like this. Why? Because 10 is not divided by 0, you always know. Okay, and if I write here 10 divided by 1, so like this, 10 is not divided by 1, but if I write 10 divided by 900, so it will be divided by, but if I write here 10, so like this, if I write like 0.5, so it give me like this, when I run it, and if I write 0.5, so it give me invalid input, please enter a valid number like this. Here you can see it. Now, here's a value occurs if the input is not a number, and the 0 division error occurs if the user enters a 0. Each exception is handled with a specified message. Number 2 is catching a multiple exceptions in a single block. First, if you want to handle a multiple exceptions in the same way, you can group them in a single except block using a tuple. Number 2, this simplifies the code when you do not need different handling for each exception. Like this one code, here you can see it. In this code, let me show you what we are doing. In this code, we define a try and then we define like some code that could raise a multiple exception. Then in the x, I write like equals to input, then input I write like enter a number. Then I write like result equals to 10 divided by x. Then I write here except, then value error, dot 0 division error, then sc. Then in the print here I like f should be an error occurred. And when you save it, and then in the bracket I write like e. And when I save it and run it, should give me enter a number. If I write here 5, so it give me nothing. When I write 0, so it give me an error occurred division by 0. If I write 0.5, should give me an error occurred invalid literal or for int with base 10 0.5. If I write 1.5, so it give me error occurred. Here you can see it. If I write here a, so it give me an error occurred even invalid literal or for int with the base 10 a. Here you can see it. Like this it is giving me. Here's the both value error and division error will be catch in the same block and exception instance e is printed. Number 3 is using a general exception as a catch all. Number first is you can use a general exception block to catch any type of exception which is especially useful as a fallback for unexpected errors. Like number 2 is, however, it is useful or best practice to handle specified exceptions first and reserve the general exception catch all for for issues. Like this one Python code, here you can see it. In this code, what we do, first of all, we define a try, and then here we define a comment. In the comment, we write some code that could be raise multiple exceptions. Then I write like x equals to int. In the int, I write like input. Then in the input, I write like enter a number. Then I write result 10 divided by x. Then I write like in the accept value error. Then in the print section, I write like invalid input. Please enter a valid number. Then I define a accept 0 division error. But then the print statement, I write like cannot divided by 0. Then I write like accept means exception SE. Then in the print statement, I write like f. And the f I write like an unexpected error occurred. And in the bracket, I write like e. And when I save it and run it, should give me enter a number. If I write 5, so it give me say yeah 10 will divide it by 5. But if I write 0.5, so it give me invalid input. Please enter a valid number. If I write 1.1, so it give me invalid number. If I write here g, so it give me invalid input. Please enter a valid number, like this. Here is the two first except blocks handle. Specify exceptions at the last block catches any other expected exceptions. Number 4 is using else with try except. The else block can be used to execute code if only if no exceptions were raised in the try block. Number 2 is this is useful when you have some code that should only run if everything in try succeeds. Like this one example here, you can see it, copy it and paste it. In this example, what we are doing, first of all, we define a try, and then in the x we define a equals to int, and in the input I write like enter a number. Then I write like result equals to 10 divided by x. Then I define accept value error comma 0 division error se. Then I write like print f. In the f I write like an error occurred. Then in the else statement I write like print f. Then the result is in the bracket I write like result. And when I save it and run it, so it gives me indent. Okay, what is and when I write here number, when I write here 5, so give me the result is 2.0. Why? Because when 10 divided by 5 equals to 2.0, let me show you in the calculator. 10 let me come here, 10 divided by 5 equals to 2.0. Here you can see it give me. And when I write here, save it and run it, so here when I write 0.5, so it give me an error code even literal for int with base 10 0.5. If I write here for 145, so give me the result is like this. And when I go here and when I write here 10 divided by 145, so it give me this and this type of one output, and it is also giving me this type of output. Here you can see it is giving me the same output. The pattern is like a one calculator. Number 5 is using a finally for cleanup. First is the finally block is executed regardless of whether an exception was raised or not, making it idle for cleaning tasks. Number 2 is it's commonly used to release resources such as closing files or network connections. Like this one code. In this code, what we are doing, first of all, we define a try except, then we write this like enter a number, like this is one same code. Okay, but here we add a one new line finally. And in the finally, I define print. In the print, I write like this block always execute regardless of an exception. When I run it, so give me enter a number. If I write 0.5, so give me the block an error occurred invalid literal for int with base 10 0.5. This always this block always execute regardless or an exception. But when I save it and when I run it, so when I save it and run it, so when I write here 5, so it give me the result is 2.0. The block always executed regardless or an exception. Okay, like this it is giving me. Like that you can do it very easily. As number 6 is custom exception handling advanced. For more complex cases, consider creating a custom exception that inherit from Python-based exception class. This is useful when you need to handle unique situations that don't fit neatly into exception types. This is one code. Let me copy this code and let me paste this code. This is the same code, okay? But when we save it and run it, should give me a custom code. Why? Because here we write like custom code. So when you run it, should give you the custom code, like that. Now, by combining these techniques, you can efficiently manage multiple exceptions in Python, ensuring your code is resilient, silent, and provides useful feedback when things go wrong. So here you can see it. In today's video of Python, I told you about how to deal with more than one exception in Python. So I hope you can enjoy this video. If you enjoy, so please like this video, share, and subscribe to my channel. Do not forget to all the notification bell. Also, never miss our any future latest videos about the Python. So now I'm in next lesson. Next video I'm making that type of videos about the Python. So for today, goodbye.